So for question 3, the question is, let fx equal to x power of 4 plus 2x power of 3 minus 3x power of 2 minus 4x plus 4. So this is our function. And then the question is, find a critical number. Critical number. So, if we want to find the critical number, we have to find the first derivative and then the factor of first derivative we will equal to 0, and then we just get our answer. So the first derivative, which is follow this function. First derivative f prime x equal to 4x cubed plus 6x squared minus 6x minus 4. So this is our first derivative. Okay. So if f prime x equal to 0, then 4x3 plus 6, 4x cubed plus 6x squared minus 6x minus 4 equal to 0. And then if we just put it in calculator, we have the factor, which is we have 3 factors: x plus 2, x minus 1, and 2x plus 1 equal to 0. All of these factors and then equal to 0, because we want to find the critical number, right? So x plus 2 equal to 0, which is we get x equal to negative 2. X minus 1 equal to 0, which is x equal to 1, and 2x plus 1, which is 0. And then we get x equal to negative 1 over 2. So we conclude as the critical numbers of fx, of function fx, are x equal to negative 2, x equal to negative 1 over 2, and x equal to 1. So we move to the next question, which is the points at which fx has a relative extremum by using second derivative test. So we have to find the relative extremum by second derivative test. So what we're gonna do is we have to find our second derivative of function fx, which is second derivative is 12x squared plus 12x minus 6. So this is our second derivative of function fx. Substitute the critical numbers in fx in second derivative, which is this function. Just put this x into this function. So we put it. Okay. So f equal to 12 we will get 35, which is 35 is more than 0. taken half, negative half, which is minus 6. And then we will get negative 1, which is negative 1 is less than 0. And then the last one is 1. Plus 12 plus 1 minus 6. And then we get 17, which is more than 0. Okay, so with this answer, we can conclude negative 2 and 1, which is we will get the answer is 35, and 17 is more than 0. When we get the answer is more than 0, so we know that any number is more than 0 is minimum points. So we write the conclusion is x equal to negative 2 and x equal 1 are minimum points. Okay, and then we also know if we get the answer is less than 0, we know that this is max point. So we write the conclusion is negative half is maximum point. That's it. So this is our answer for question 2. So we move to the next question, which is find the interval on which fx is increasing or decreasing. Okay. So if you want to know how to find increasing or decreasing interval, we can use the first derivative and the critical numbers that we get in question 1 just now. Okay, so we will put into the table. Okay, we will put into the table, which is f prime x equal to 4x cubed plus 6x squared minus 6x minus 4. And then our critical numbers, which is negative 2, negative 1 over 2, and then 1. We can also put it on infinity sign. And then this is negative infinity. So between negative infinity and negative 2, we just put we can put the near number, which is negative 3, and then this we can put negative 1, 0, and 2. Okay, why we need to write this? Why we need to write this number? Because if we put the critical number, which is these three numbers, into this function, we will get 0. 0 has no operation, which is 0 is 0, not negative and not positive. So if you put negative 3, which is near to negative 2, and then we put to this function, we will get the sign, we will get the answer, and then the answer we will see the answer is negative or positive sign. For this answer is negative, and then we if we substitute negative 1 into f prime x, we will get positive, and then and then this negative, and then we will get positive. Okay, so we know that if we get negative sign, the monotonicity is decreased. Okay, and then monotonicity for positive function will increase. This decrease and this increase. So from this table, we know that this minimum point, and then this is max point, and this is minimum point. But the question is want to find the interval function. So for increasing interval, is, so if we see at this monotonicity, this monotonicity is decreasing, decreasing, and this decreasing, and this increasing. So increasing interval is between -2 and -half, and 1 to infinity. So -2, -half, and 1 to infinity. For decreasing interval, we get -infinity to -2 and -half to 1. So this is our interval increasing and decreasing. So for the last question is, we have to sketch the graph. So before we sketch the graph, we have to find y value. Okay, so for f -2, we get just substitute -2 into function of x, and then we get 0. So the y value if x is -2 is 0. We're gonna do the same way for -half and 1. And then we will get 81 over 16. So x equal to 1. Okay. And it's 3, 1 power of 2 minus 4, 1 plus 4. You will get 0. So we will start sketch the graph because we already have x value and y value. Okay. Okay, so okay, we draw first. Y exists and x exists. So we have -2, we have negative half, and then we have and negative 2. When x is negative 2, then y is 0. When x is negative half, our y value is 81 over 60. And x equal to 9, y equal to 0. Okay, we already put our point, and then we have to put the line onto this. So it's gonna be like this. So the last one is put our function. Don't forget. Okay, so our function is x power of 4 plus 2x power of 3 minus 3x power of 2 minus 4x plus 4. So that's it for me for question 3, and then I will pass to the next presenter, which is Kayla, with grade science question 4.
We continue with question 4. Determine the relative extrema of function f(x) is equals to x minus 2 to the power of 2 over 3. So here we want to find the relative extrema of a function. Before that, we need to differentiate the function first. So if we differentiate the functions of f(x) is equals to x minus 2 to the power of 2 over 3, we can get the value of 2 over 3 times x minus 2 to the power of negative 1 over 3. And then we rearrange the number, we can get 2 over 3 cube root x minus 2. Next, we want to find the critical number. So we need to make sure that f prime x is equals to 0, then we can get the value of x is equals to 2. So here, the function is differentiable everywhere, but undifferentiable when x is equals to 2. So here we can get the critical point is 2, 0. Next is monotonic point. So what is monotonic? Monotonic is a domain of a function when it's increasing or decreasing. So here we have two interval, which is negative infinity to 2 and 2 to positive infinity. So we analyze the function in the following table using the first derivative test. So here we have two interval, which is negative infinity to 2 and 2 to positive infinity. So we just need to pick one value from between both interval. So here we pick 0 and 4, and then we substitute the value into the f prime x function. We can get the sign, which is the negative and positive. For the first interval, we can get the sign of negative, and then the second interval is a positive. So what's the meaning of negative and positive sign? Negative means the interval is decreasing, and the positive sign means the interval is increasing. So here we can conclude that f prime 2 is equals to undefined is a relative minimum of a function f(x) is equals to x minus 2 to the power of 2 over 3.